We picked a custom West Coast drivetrain using Versa blocks and West Coast ball shifters, using 25 chain on 18 tooth sprockets and 4-inch Coulson wheels with the press fit hubs. We chose to do this because the Coulsons are the grippiest wheels that we had access to in this time period. So we mounted the wheels just far enough inwards that there's about a 1/4 inch of clearance between the edge of the wheel and front of the robot. So even when going to roll up onto the ramps and stuff, the wheel catches first and still allows us to get up there while giving us the ability to have pushing power in our low gear on the gearbox and push other teams around.
Design we currently have is going to be a box with 2 rollers on the front that are spring-loaded that will grab hopefully the playing point or playing piece, whatever it's called, and suck it in. We're currently having some issues going through some prototypes right now, and hopefully we'll get it fixed in a couple of hours. We picked this design because we figured it would be the easiest to make out of all the others. It requires the least moving parts in theory. The other design we had was an elevator feature, which would use belts to draw the box in and lift up and down. We figured there were at least 3 or 4 different moving parts, whereas this design has only 2 on the arm itself. My job is to work on the intake piece, the rest of the arm is with another sub-team, and so we picked this design because it is fairly simple.
Okay, so when we were doing our initial strategy, we thought about how to achieve the greatest range of motion and be able to place in both the scale, low and high, and how, if possible, that could be used to help our climb as well. Well, initially we kind of thought of a retractable elevator so that we stayed within the starting configuration constraint and would be within the extension zone constraint as well, really easily. But we quickly realized that that kind of elevator is really hard to implement very well in just a few days. So we moved on towards thinking about a single jointed or perhaps a double jointed arm, so with a wrist as well. And that would help us achieve those ranges of motion. The only problem with an arm is that we end up with different constraints at different points in its trajectory. So for that to work, we need to ensure that the programming team can easily turn the wrist and keep it within the extension zone at all times, because that 16 inches is really easy to protrude outside. And when we realized the programming that would be required to go into that, basically a complete PID subsystem on everything with motion control is very hard to do, especially in 3 days. Although had we had the full 6 weeks, would have been definitely something we would have liked to try. We switched to a system that would have the cube manipulator on the inside of the arm, which would then get retracted into the arm. So it's just a single jointed arm now, but you can imagine that the mechanism just kind of disappears inside of it at certain points. So that's much easier to implement. Think of it as a 2-position thing. So initially we thought of using pistons, but then we realized that the climber also had a need to lift things up. So already we were retracting the intake. Well, if we strengthen it up and we make that part of the climber, and this is one of our working theories right now. Obviously it's only the second day, so we hope it works, but it's still being prototyped, is to use that retraction to also grab onto the bar and pull the robot up. So with that all looked at, we just need to build that and prototype it and improve it.